example I want to look at is going to be a mixture problem. Now, mixture problems come up in a lot of different ways, but they all boil down to the same thing, that we're mixing two different things together to obtain a third thing. So in this particular case, we've got a candy store, and we've got these M&Ms that are worth $2 a pound. We've got some trail mix worth $1.50 a pound, and we're going to mix them together, stir them all up, and call this stuff party mix. And we're going to charge $1.80 per pound. So in this case, we're being asked how many pounds of the M&Ms and trail mix should I be mixing together so that the correct amount to charge for the 50 pounds is $1.80 per pound. So let's first of all organize the information of what's going on. And then let's try to stop doing any math and just take a common sense approach of what's going on. So I always draw mixture problems the same way. I'm going to take a bin plus a bin equals a bin. And I'm going to throw some information into these bins. Now inside the bin, I'm going to put the concentration. That's what's always going to happen in these problems, is there's a concentration involved. So in here, I'm mixing M&Ms with trail mix to get party mix. And the concentration of the M&Ms is $2 per pound. Now, sometimes concentration is given in percent. Sometimes it's per pound. There's always going to be a per in there when talking about the concentration. The trail mix was $1.50 per pound. And the party mix, $1.80 per pound. Now we do know that there are 50 pounds of the party mix, and underneath is where I'm going to put the amount of whatever it is that we have. So this is all the information that was given to us, and I want to talk about a common sense approach of how we're going to approach this from a common sense perspective. And what I always like to do for the common sense approach is to say, what if, and don't write this down over in our actual work, what if it was 25 pounds and 25 pounds? What if I just mixed equal portions of each? So if I had some stuff worth $2 a pound and some stuff worth $1.50 per pound, and I mixed them together, equal amounts, how much would I charge? Now, some people would say add them together and make it $3.50. Now, that's ridiculous if we think about it, because neither one of them is worth $3.50. The most expensive thing we're putting into this mix is $2 per pound. So we know we can't be more valuable than $2 per pound. The cheapest thing we're adding into the mix is $1.50 a pound. So we know that we're not going to charge less than $1.50 a pound. That wouldn't make sense. What makes sense if we do equal portions of each is that if we did equal portions, it would be the average. If we had equal portions of 25 pounds and 25 pounds, then we would charge $1.75 per pound, right in the middle. Now, we don't actually want to charge $1.75 a pound. We want to charge $1.80 per pound. So we got to say, all right, well, if I need to have a little more value to this mixture, do I want more of the cheap stuff, or do I want more of the expensive stuff? And if we want to raise the price of it, we want more of the expensive stuff. So if we're looking at charging $1.80 per pound, then we better have more M&Ms. M&Ms are worth more. So that's going to raise the price that we can charge if we include more of the expensive stuff. So instead of a 25-25 split, we're expecting a little more like maybe 30-20 or maybe like 28-22, something like that. We're expecting a little bit more of the M&Ms than we are of trail mix. So again, some of the things that we pointed out, you might want to jot these down off to the side somewhere in your notes, is before we even looked over to the right-hand side of what we want to charge, we know that we're never going to be more valuable than $2 a pound, because that's our most expensive thing, and we'll never be less valuable than $1.50 per pound. That's how these mixture problems work, is the end result's going to be somewhere in between the concentrations. We know that if we did equal parts of each, it's the exact average. Now this problem is not the exact average, it's a little more valuable, so we're going to have more of the valuable stuff. All right, so now let's get to actually solving it. We need some variables. We need to figure out how much M&Ms and how much trail mix should be added together. Now we could use two separate variables if you really wanted to. I don't really want to, so don't write this down. I'm just going to point it out. We're going to eventually be able to approach this with common sense because this was actually a problem from our prerequisite course. So if I don't know how much, well, I know if I have X pounds of M&Ms and I have Y pounds of trail mix, if I add them together, I need to get 50 pounds. So what is Y really? Y is 50 minus X. So instead of actually using a Y over here, oops, I'm going to erase that. Instead of using a Y, let's just use 50 minus X. That way we don't even have two variables, we only have one variable. And this should make sense if we start throwing some numbers into there. If I had 20 pounds of M&Ms, I would need 30 pounds of party mix. How'd I come up with 30? I did 50 minus 20. If I had 40 pounds of M&Ms, I would need 10 pounds of trail mix. Again, that comes from 50 minus the 40. So 50 minus X gets us how much trail mix we need. Now to turn this into an equation, the way that this works is we multiply those two values, multiply those two values, and multiply those two values, and we keep the mathematical symbols that were already there. Now the reason that's how this works is because if I have 25 pounds of M&Ms at $2 per pound, I'm going to multiply those two things together, and that's how much money worth of M&Ms exists in this mixture. If I multiply the 150 times 50 minus X, that gets me how much total money's worth of trail mix I have. And if I add those together, it better be the amount of money worth of party mix that I have. And if we look at what's going on here, we now have one equation, one unknown. This should be pretty easy to solve. So 1.5 times 50 is going to get me 75. Distribute the 1.5 over to the X. And 1.8 times 50 is going to get me 90. I can combine like terms on the left with the 2x minus 1.5x. That's going to get me 0.5x. And I can subtract 75 to the other side. That's going to get me 15. And if I divide by 0.5, I'm going to get x equals 30. Now that I have an algebraic answer, I need to go back to my original problem and figure out how to answer the question and to see if it makes sense. The question asks, how much of each do we have? So it's asking how many pounds of M&Ms and how many pounds of trail mix. Now remember that we defined X as the number of pounds of M&Ms. So we can say 30 pounds of M&Ms. And then if we come back to our problem, for trail mix, it was 50 minus X. 50 minus 30 would be 20 pounds of trail mix. Now to make sure this answer makes sense, we do have a total of 50 pounds, and going back to our common sense approach, this was actually one of our guesses. We said maybe 30-20, maybe, I don't know, 28-22, but this was actually one of our guesses. So it makes perfect sense because we already got this through a common sense approach.